What's up, Node.js developers? Bun 1.0 is here, and in this video, we're gonna get our hands dirty and explore the possibilities that Bun is bringing to the table for us JavaScript developers. We're also gonna do some performance testing and put it head-to-head with Node.js and NPM tools and see if it's really that fast as we see in their documentations. So if you're interested, let's hit the intro and let's get started. Hello everyone, my name is Vadim, and in today's video, as I said, I prepared for you. We're gonna explore Bun, but first of all, let's have a look at what Bun in general is. So, in a couple of words, Bun is the Swift knife, is the everything that you need to run, build, and deploy JavaScript and TypeScript applications. So the goal was to simplify and put together all the necessary tools that you would need nowadays to run Node.js applications with dozens of packages that you need there. So first of all, Bun as a JavaScript runtime is, I'm gonna explain this part by comparing with what we already have out there. So the Bun JavaScript runtime is here to, in a way, replace Node.js. It's a drop-in replacement for Node.js. And in this video, I will want to test how easy it is to switch from using Node.js to Bun in a real project, if we need to do any changes or something like that. The benefit is, of course, coming with speed because it runs on a different JavaScript engine, the JavaScript core that is from Safari, while Node.js is running on the V8 engine that is powering Google Chrome. It also has a lot of built-in APIs, for example, the server, WebSockets for reading files, hashing passwords. And in the end of this video, we're actually gonna use a lot of the built-in tools that Bun is bringing out of the box. So no packages needed for all of this. The next step is Bun as an NPM-compatible package manager. In this scenario, Bun can replace the NPM or Yarn tool that you're currently using, and it comes with a lot of improvement in speed as well. As you can see from their homepage, NPM runs 29 times slower, and Yarn runs 33 times slower. So we're gonna see in a real application, we're gonna initialize a React Native application with NPM and Bun and see the difference there. And I think this is the easiest way to get started with Bun because you don't have to change a lot of things. You can use Bun locally in your development environment to manage your packages, and because it works with the same package.json, you can use NPM, for example, in production, or someone else from your team can use NPM and you can use Bun. That's perfectly fine. Bun is also a test runner, and you don't need Jest or any external tools to run tests. And as we can see, it's also way much faster than existing solutions out there. So I think we have a big picture of what Bun is. Let's go ahead and install it and start using. And I'm gonna start, actually, before we do that, let me quickly summarize the agenda, like the plan for today. So first of all, I want to show you how we can use Bun as a package manager, because as I said, this is the easiest way to get started, and you don't have to change a lot of things. You can try it out, you can see the performance benefits, you can use it in your project, and you can keep using NPM or Node.js as the runtime. Then I'm gonna get into the runtime because this probably takes a little bit more time to switch from Node.js to the Bun runtime. You'd have to test everything to make sure everything is working. But what I want to test here is, first of all, how easy it is to use Bun as a drop-in replacement for Node.js, meaning as little changes as possible, just switching Node.js to Bun and seeing if it works. We're going to use it on a real project, and we're going to do some performance testing for that to see the difference between how how Node.js is handling a lot of requests incoming and how Bun is doing that. After that, we are actually gonna get to a lower level and start actually building an HTTP server from scratch. We're gonna do a very simple and minimal HTTP server using Bun. We're gonna write it natively. We're gonna also do performance testing there. We're gonna see how we can use tools from the Bun ecosystem, like managing files, reading files, using SQLite database, hashing password, and so on. So that is the plan. If you're interested, make sure to stick to the end and make sure to subscribe to the channel, because we are actually have a huge goal by the end of this year. For this quarter, for the last 3 months of this year, we set ourselves a goal to reach 100,000 subscribers. And if you can take a second to pause the video, subscribe to the channel, that would mean the world to me and to the whole team. I know that's possible because 99% of you watching this video are not subscribed. I see this from the analytics. And if some of you will decide to do that, we can actually reach the goal by the end of the year. So yeah, thank you very much. And now we can actually get started. But yeah, I prepared, as always, a guide for you to easier follow along. So if you go into the comments, you're going to see the step-by-step guide here, which will open the guide on our website. And here we can follow all the steps with some even screenshots that to be able to follow along with me. So let's get started with installing Bun on our system, and we're gonna do that using the command that we see right away on the header if you go to bun.sh. So let's copy this one here. I'm gonna move it to a different screen. Here I'm gonna open a terminal. Hello everyone who is watching this live. How are you doing, guys? Are you excited for this one? It's echoing. Oh. Hopefully now is better. Oh. Sorry for that. Oh boy. I'm so sorry. I just realized that the video is playing in the background and probably the sound was terrible. Was it like completely bad, or can I continue? So sorry for that. Yeah, now it's better. Now I turned it off. I'm wondering if the intro is like terrible. We are 8 minutes in. It wasn't that bad. Okay, I'm gonna trust you. If everyone drops from the first 20 seconds of a video, you are to blame. All right, thank you very much. So let's continue. So as I said, I'm gonna open a terminal here. Let me go to a project, here, and I'm gonna do a make dir. One second. All right, so I navigated to a place where I will keep my projects, but actually for the install command, that shouldn't matter because we are installing it globally. So as I said, let's grab the command from the homepage of Bun and install it on our system. At the moment, it's only supported on macOS and Linux and VSL. They have, I think, limited support for Windows, but yeah, on macOS and Linux, everything should be supported. So we see Bun was installed successfully, and we can do Bun probably version. Yes, 1.0.6 at this moment. Perfect. So we already have Bun installed. Now, as I said, we're gonna test Bun as a package manager. So what I'm gonna actually test here is I'm gonna create a dir Bun PM or let's do actually package managers, and here in these package managers I'm gonna create two folders, one for Bun, for a Bun project, and one for a Node.js project or an npm project. Now, as you can see, I have two folders, one with Bun, one for Node.js. What I want to do now is, let's go ahead in the Node.js folder first and try to install a package using npm. So to do that, we know to install a package with npm, what we do is do npm install, and we can paste the name of the package that we want to install. I'm gonna go with Express. It has some dependencies on its own. So as we can see, npm installed Express and the other 58 packages in 3 seconds. So this is our first test. And if I'm gonna go in the Bun directory right now, and if instead of using npm to install the Express package, if I'm gonna do Bun install Express, let's see how fast Bun is doing that. All right, that was already done. The same 58 packages were installed in 647 milliseconds. So compared to 3 seconds, that's quite a lot faster. And if you want a visual guide of all of this comparison between Node and Bun, we can actually do that here and take some notes. For example, if we want to compare, let's just take some notes here. So installing Express using Node.js took 3 seconds, with Bun took 0.6. And that's 5 times faster. Should we be more precise? 4.7. And the first one is just saying 3. Okay, so as we can see, with Bun, it's as easy as it is with npm to install packages. It's the same syntax, install, and then our package name, but it is doing this much faster. All right, let's see how Bun is going to perform with a little bit more dependencies or a little bit bigger project. And every time I'm installing or initializing a blank Expo or React Native project using npm, it actually takes quite a lot of time. And more recently, when I was exploring why I don't have any space on my device, I realized that every React Native project has around 0.5 GB, more than 500 megabytes of Node modules. So that's why npm is taking so much time to install it. But let's see how we can use Bun to manage our React Native project and the packages that we install. So for this experiment, I'm going to, let's create a new dir Expo project. And we're going to do the same here. We're going to first initialize an Expo application using npx create Expo app. Here, let's call it npx Expo app. And this is using the npm and the notJust ecosystem to initialize an Expo application. So first it downloads a template, then it runs npm install to install all the dependencies of this blank Expo project. So let's press enter because this command will take a little bit of time. It's usually taking for me probably around 60 seconds. So also depending on your network, of course. Yes, let's wait. Hello, Fabio from Brazil. Thank you very much. Tammy, hello. Octavian, Robert, Analit, Rogelio. How are you doing, guys? Yeah, so as you can see, this is already taking a lot of time. And even if it's 60 seconds, when you have to, for example, when you have to install and create and set up a lot of projects, if you're working on multiple projects, or if you're like me, starting a new React Native project every day, then you're wasting a lot of time. As we can see here, it actually took 58 seconds to create the Expo application using npx. So create Expo application, it's 58 seconds. Let's go ahead and do the same command using the same template from Expo to initialize it with Bun this time. So if I'm gonna do clear, yes. What I can do is we're gonna do Bun create, and here Expo, and we can call it Expo or Bun Expo. So this time we're using the same template, the same create tool, but this time we're doing it with Bun as a package manager, and I didn't even finish that sentence. Bun already finished installing the project, and it took 5 seconds, 5.03 seconds, which is more than 10 times faster to simply initialize a Expo blank application. I think this is impressive, and for us React Native developers, this is in a way the most we can use out of Bun, because we're not going to use Bun runtime inside React Native, but as a package manager, Bun is already bringing a lot to the table, a lot of performance and faster install times when you are installing dependencies. Yes, this will not relate to a faster running application in production, but the faster you'll install dependencies, the faster you'll understand that, I don't know, you need another package to install, and it's gonna speed up the development time, and you're gonna have more fun, probably. Anyway, so as we can see, it's a lot faster. Now let's go ahead and maybe some outro words about Bun runtime, because we have covered most of it. There is nothing much more to go into depth into the package manager, because what we are using a package manager for is to manage package install. Behind the scenes, it's very important how the package manager caches all the dependencies. For example, npm downloads everything into the node modules. Bun is caching something on the global level. So this command, the first time when you run it, you might get higher numbers, because this is not the first time I'm running Bun create Expo application, and this means that some of the packages might have been taken from the cache. So that's where a lot of performance benefits is coming, but nonetheless, it's faster. And if you're using it multiple times, you're gonna hit the cache quite often. So downsides, I don't see any other than having to use another package. npm is coming from Node.js. You're still gonna need Node.js in most of the cases on your system if you're developing React Native Expo applications. And the benefit of using npm is that it's coming out of the box. With Bun, you just simply have to install a little tool, and then you can replace all the npm commands with npx. And not only that, but also the npx, that is the executable of npm. You can do that with Bun as well by adding an x at the end. So all the npm command will become Bun commands, and all the npx command will become bunx. All right, that's it. I'm not gonna stop here more than it is necessary. Let me check if there is any questions in the live chat, and then we move on to the runtime. Hello, Tammy from Hong Kong. Roman from Adeje, hello, how are you doing? We met with Roman here on Tenerife. Yossi from Iraq, hello. Are you still doing boxing? No, I done boxing, I don't know, 3 years ago or something like that when I was in Belgium. studying. Is it ready for Expo Router v2? So the Bun runtime, I don't see a way at the moment to be used in React Native, but Bun as a package manager to install commands like bun install, I don't know, date picker or something like this, you can already use it. No problems. And you can also use it with EAS, the Expo application services, to manage your packages, install them in the cloud when building the application with EAS. Has there been any word of when it will be available for Windows? For Windows, as I read in their documentation, they have some support right now. I think it's still experimental. Windows. So macOS and Windows. Bun provides limited experimental native build for Windows. At the moment, only the Bun runtime is supported. So probably Bun as a package manager is not, as I understand. The test runner, package manager, and bundler are still under development. The following commands have been disabled. So yeah, you're not gonna be able to run bun install, bun add, remove. You're gonna be able to simply use Bun as a runtime on Windows for now. On macOS and Linux, everything is supported. Anyway, let's go ahead and continue our exploration, and we're gonna go to Bun as a runtime. So as we can see on the homepage, the Bun is a JavaScript runtime. What do we see here? It's fast. That's the first thing that we see, because it's running with JavaScript using the JavaScript core engine, which is powering Safari. So this is the difference. Bun is using JavaScript core, which is powering Safari. Node.js is using the V8 engine, which is powering Google Chrome. So yeah, that's the difference. So yeah, this is what I was looking for, the drop-in Node.js compatibility. Bun aims to be a drop-in replacement, which means that you can simply swap Node.js with Bun without changing anything, and it should work out of the box. So that's the thing that I want to explore. And for this tutorial, I found a project, an application inside the Prisma templates. And this application, if you open the URL from the guide, this application is a full stack application that is using Next.js on the front end and Express here, Express and Prisma client on the backend. So what I want to do is simply clone this application, install the dependencies with npm first, run the application using Node.js runtime first, see how it works, do performance testing, and then do the same thing, but this time with Bun. Without doing any changes to the code, I want to download the application, the source code. I want to install the packages with Bun, and I want to run both the backend, the Express API using Bun as a runtime, and the Next.js application on the front end as well. So let's go ahead and do that. The first step is you could try to download this example project using this command, but for me this one throws an error. So what I have to do is use the alternative method, basically cloning this repository. So let me clone it. And here in my project, what I'm gonna do is here, let's simply clone the Prisma examples repository. And then we're going to navigate to the example that we are interested in. There are a lot of projects, but we are interested in the REST Next.js Express. So simply copy this cd command, paste it in our application, And now we should be inside a project with a folder backend and frontend. I will open this project. You can also write pfd to see the full path until this project. And let's go ahead and open it inside Visual Studio Code. I have a small shortcut when I write code, and the file path, it will open it in Visual Studio Code. If you don't have this, just simply open Visual Studio Code and find this path that you see above. Open it there, and we're gonna start it from there. So here is Visual Studio Code of the full stack application, the template that we found on the Prisma examples. And what I want to do here, so the steps are, there are two folders. Backend, again, this is the Node.js and Express application. As you can see in the packages, it has Express and it has Prisma. And on the front end, this is the Next.js application. So it should have somewhere here, Next 13. Perfect. Let's go ahead and first, we're gonna start with notJS and npm. Let's open the backend folder. Let's navigate to the backend folder. I'm gonna open it like this, maybe even zoom in a bit. And the first step is to install dependencies. We're gonna do that with npm, so let's do npm install to install all the backend dependencies. We're gonna also take notes of all of these timings to compare it with Bun. And we can see that for the backend, it took 8 seconds. So let's go ahead here, and maybe we can add a new row here. Node.js full stack up. And the first metric is going to be backend install. It took for us 8 seconds. Now what we have to do is we have to seed the database. Prisma has here a seed file with basically some data that we can fill in the database for us. So the only thing that we have to do is simply run npx prisma migrate dev name and give it a name. So we are migrating the Prisma schema, and we see that the init migration is applied, and it took 48 milliseconds. I think we're not gonna see any changes here with the Prisma, so that's why I'm not gonna even write it down. It should be the same for Bun as well. Perfect. So the last step is to actually run the server. So let's run it with npm run dev. And that means that our server is already ready. So if I'm gonna click on this URL, it should open in a new page. It writes cannot get, but if I'm gonna add the /feed, then we're gonna receive a JSON with items. You don't have to do that. You don't have to understand what's the application doing, because in the next step, we're gonna run the front end and we're gonna see visually what's happening. But yeah, as I said, with the backend, we are done. Now let's go ahead and do the same for the front end. I'm not gonna close this terminal because here is where our server is running, the backend server. Let's press on the plus sign to start a new terminal, and let's navigate to the front end now. I'm gonna start with npm install to install all the dependencies, not npx, but npm, to install all the dependencies for our Next.js application. It's taking a little bit more time than the backend, and we see that it took 12 seconds for all the packages. 12 seconds, and this one is front end install. Okay, we have information about the front end. And lastly, we have to run our front end by doing npm run dev. npm run dev. And we detected something, and it's ready. We can open localhost at port 3000. If I'm gonna open it here, we see some problems with a link. And if you also have this problem, let me show you how quickly we can fix it, and I'm not sure why it's still here. But open frontend, components, header, and in the header, find the link that has a child A. It should be the last one. The /create is a link with a child A, which now is not the recommended way. That's why we get the error. But if we simply add the legacy behavior to the link, everything should work as it was working. I mean, as it's supposed to work, because we didn't see it working actually. So right away, here is our basic website, a blog with local database, with Prisma, with a REST backend and a Next.js frontend. We can go ahead and read the information about posts. We can delete them. They actually are deleted from the database. We can go ahead and actually sign up. For example, Vadim, notjust.dev, sign up. We can create a draft, for example, hello world. Offer should match my email address from the database. And here, how are you? We can create it. We're not going to see it right away on the page, but if we go to the drafts, or on the page we're not going to see, but in the drafts we see it. If I go to the draft, we can publish it, and it gets on the home page here. So it's quite a lot of features there, but we don't care that much. What we wanted to see is to do some benchmarking and see if a complex application like this with backend and frontend will be easy to switch to using Bun as the runtime. Before we actually go before we move to Bun, as I said, I want to do some performance testing, some stress testing. And actually before that, I will also open backend source index. And here, remember when we navigated to localhost 3000, this is frontend, but if we go to 3001, this is the backend, this is our REST API. And we see that it gives us an error, cannot get home. What I want to do is, I want to simply add a hello world endpoint to this route. And to do that, I'm gonna add app-get at the root endpoint. It's gonna have request response, and it will simply do response dot send hello world. Now, if I'm gonna refresh the application, it's still saying cannot get because we need to restart the server. Open the terminal, go to the first one that is running the server, stop it, and let's run it again. Now, if I'm gonna try the request again, we see hello world. So this is going to help us benchmark, like it's gonna be a very simple endpoint that will simply return hello world, and we're gonna use it for benchmarking as well. So now about the benchmarking and about load testing the application. We're gonna do that with a tool called, where is it? We're gonna do that with a tool called Bombarder, if I pronounce it correctly, probably not, but this one was recommended in the Bun docs for the benchmarking. Because when doing benchmarking, you should use a benchmarking tool that is faster than the server itself. So something like AutoCannon, they are saying that is not fast enough. So that's why they're recommending this Bombarder. So let's go ahead. I already installed it. You can see how you can install it in their documentation. You can download it from the release section from here, or you can install it using Go, or you can watch me how I do these performance tests. Yes, tests. So I have it installed. What I want to do is I want to send a lot of requests to our REST API and see how long our backend takes to respond to an average request, and also how many concurrent requests it can handle at the same time, or in 1 second. So using this command, we have our server running here. Let's open a new terminal and let's go ahead and execute this command. What it will do is it will use 125 concurrent connections, and it will send 100,000 requests to our localhost port 3001, which is our server. So basically we are stress testing the hello world endpoint. What we are interested in is to see the data, to see how it performs. So it takes a bit of time. In total, it took 7 seconds. On average, it handled 14K requests per second, but maximum it only did 17K. And it took on average 8.5 milliseconds to execute to handle one request, an average request, and the throughput 4.63. Let's go ahead and take notes of these ones. So I'm gonna do it like this. Total time was how? 7 seconds? Yes. Requests per second average was this much. I want to do also maximum request per second. So request per second maximum is this amount. What else I'm interested? Should I do the average latency? Latency average. Let's do it like this. And maybe the throughput, 4.63. 4.63. Throughput is not very important here because we're not sending a lot of data. But anyway, so this was, if I'm gonna do it like this was the hello world endpoint load testing. Now let's do the same testing, but this time not for the hello world, but for the feed. The /feed endpoint will return a JSON with all the posts that are published, that are not yet draft. So behind the scenes, this feed will do also some Prisma requests, will find many, will return. So it will do a little bit of work other than sending hello world. And I think it's a good way to test some more realistic use case as well, not only hello world request, to compare and see the results. So let's run the same bombarder command, but to the localhost and then /feed. Let's see how it performs here. What is legacy behavior doing? You are asking this about the front end components header for the link. So in the past, you were defining a link that is imported from Next, and inside it you were defining an A tag, which is a native HTML link. Nowadays, you don't have to do this. You don't have to. A link will automatically render the A inside it, so you don't have to put A. That's why now this is how you're supposed to make links. But if you are still using this syntax, that means that this is legacy. So by simply specifying that, hey, I know this is legacy, it will be removed later, but I need some time to update it, you can add this property. But that's a bit off topic. So let's go back to our stress testing. So for the feed, we have the results. It took in total 15 seconds. So let's put in our data. This is the feed endpoint. Let's do it like this. Total, it took, as I said, 50 seconds. Yes, 50 seconds. Request on average, 6,000. Request on average, 6K. And maximum was 12K per second. Let's not do dot. It's too much. Latency average was 18.6. And throughput was 733. Okay, so we have our numbers. We know some numbers of how fast the package manager worked and also how fast is the runtime working when we are using Node.js, NPM, and the whole Node.js ecosystem. Now, in the next step, we're gonna do the same, but this time using Bun. And as I said before, I'm curious about how easy it is to use Bun as a drop-in replacement and then running the same performance testing and comparing it. So it's going to be fun. Let's go ahead, and what we're going to have to do is basically we're going to do the same, but this time with Bun. So I'm going to actually close this Visual Studio Code instance. In my terminal, I'm going to go up a couple of steps until I get to my Bun Explorer folder. Here we have the Prisma examples. This Prisma example is the Git repository that we cloned. And from that moment, we're gonna do everything once again. So starting with cloning the Prisma examples repository, I don't want to have like traces of node modules and so on. So I want to start completely from scratch. So let's copy this command from our guide under the benchmark with Bun. And it's the same git clone command, but at the end it will save in the Bun Prisma examples. And if I do ls now, we should have both. We have both Bun Prisma examples and Prisma examples. They are the same basically repository. The only difference is the tools that we're gonna use to run it. So now we're gonna go to the Typescript to the REST Next.js Express example from the Bun Prisma examples folder. And here I'm gonna open it in Visual Studio Code again, as we have done previous time. The same project, the same frontend and backend, they are clean. They don't have a node modules yet because we just cloned the repository. So the first step is going to be to install the dependencies of our backend. Now using Bun, let's go ahead and open a terminal and navigate to our backend folder. In the backend folder, let's go ahead and run Bun install to install all the dependencies. Previously, let me remind you, it took 8 seconds. Now it took how much? It actually errored out because there is a duplicate package which NPM didn't complain about, but Bun is saying that, hey, there is a duplicate package. And indeed it is. Like if you open backend and package.json, you're gonna see that types node is available both in dependencies and dev dependencies. Let's delete it from somewhere. I will delete it from dev dependencies just to be safe. even if most probably I should have deleted it from dependencies, but at least one we should delete. And we're gonna do bun install again. Remember previous time it took 8 seconds. Let's try it right now. That's it. That was it. Like, I'm not even kidding. 58 milliseconds and the same 102 packages were installed. That's quite impressive. And 58 millisecond, that is 0.05, right? Or am I tripping? How many milliseconds? No, that's 0.5. You're gonna laugh, but I'm gonna Google to double check. There is 100 milliseconds. No, there is 1000 milliseconds. I was right. There's 1000 milliseconds in 1 second. But still, I'm gonna check. 2 seconds. It's 0.058. I was right. And if we compare the difference here, it's 137 times faster. Not in percentage, it's x 137 times. That's impressive. Okay, let's go ahead and migrate Prisma. So previous time we migrated Prisma using npx Prisma migrate. As I said, we can before we were using npx with bun, that would be bun x Prisma migrate dev -- name init. Let's do that. It worked. However, if I will look at bun documentation at the bottom, if I'm gonna search Prisma here, get started using Prisma from the ecosystem, there is a note here. At the moment, Prisma needs Node.js to be installed to run certain generation code. So that means that how I understand, when running some migrations, it would be better to run them, to have Node.js installed on the system because Prisma depends on that. But this is again only in development, so it doesn't make a lot of difference. At the end of the day, the Prisma database has been seeded correctly, and it took the same amount of time as it took with npm, which I suspect that behind the scenes, both of them are using Node.js at this moment. But yeah, anyway, in the next step, we're actually gonna start the server. So to do that, I'm gonna execute, clear. To run the backend server, previously we ran npm run dev. If I look in the package to see what is the script run dev actually doing, the script run dev is simply executing the source index.tsx. Let me simply do bun source index.tsx. TS. In this way, I'm running our server using bun, as simple as that. Our server is listening to port 3001. I'm gonna go ahead and the same way add here the hello world endpoint. We're gonna need it to test it a bit later. So get / that's gonna be a request and response. And it will do response.send hello world. Now I can restart the server right away and try to navigate to localhost 3000. I'm gonna go here. I see hello world. That means that our server that now is running with bun runtime is actually running correctly. That's good. That's good. Now what else? Yeah, with the backend we are done. Let's go ahead and do the same for the front end. For the front end, I'm going to navigate to front end. And here I'm going to start with bun install. And that was finished in 4 seconds, 94 milliseconds. No, it's not 94 milliseconds, Vadim. You learned that today already. So front-end installation is 4.9894. That's 3 times faster, still impressive, but probably a lot of these have not been cached. So the next time you're gonna do that, even if, for example, I'm gonna do a ref node modules, and maybe even the bun lock, the next time I would expect it to run faster. Yes, as you can see, this time it runs in 141 milliseconds the second time, because it was already cached locally on my system. So yeah, it didn't have to reinstall them again. That's actually impressive, but it's tricky, like which one to consider, because npm simply is not caching them. So, but anyway, like I'm gonna add here one more line, front-end install, or let's do front-end second install. That would be also 12 on npm, and here it was 0.141. So for the front end, yeah, we still get crazy numbers, but only the second time we do this. Question from the chat: Bun not support Windows? It has limited support. As I read just now in the documentation, the package manager is not supported yet, but the runtime has limited and experimental support. So you can give it a try, but it's not going to work similar to how it is on macOS and Linux at the moment, which is stable. All right, so we installed. Last step is to run our server. So what we can do is, if I'm gonna go here to the script Next.js, well, to run the server, I'm gonna do bun run dev, and you'd expect that this would actually run it with bun, but it will respect Next.js wanting to run on Node.js. So to force it to run with bun, I'm gonna add option -- bun here, which sounds weird, bun run dev, but it will do its job. So yeah. It has the same error with a link. So I'm gonna go again in components header, and somewhere at the end where we have link and I'm gonna do legacy behavior, and let's try to run it again. Okay, it's ready, it's compiled. This is also probably something that would be interesting to see the difference, how fast it compiles and runs with Bun and with Node.js. Probably not a big difference, but anyway. So I'm gonna try the same user interface again, this time running with Bun. I know I'm not gonna try all of the features. Probably it's gonna work. So I'm gonna leave it like this. Because the more interesting part here is the performance testing, the load testing on our API. So let's actually get to that part, the bombarder part. So what I'm gonna do is I'm gonna run the same 2 tests, sending 100,000 requests to our server, to the hello world, and then to the feed. Starting with the hello world, let's see that in action. And that's finished. In total, it took 3 seconds. Let's put that in our spreadsheet. So hello world endpoint, total time 3 seconds. We can calculate this already. can format them as number. Request per second average, 31k. So this is already twice as fast, twice as many. The maximum is 36. Latency average 4.01, twice as fast, and throughput is 446 as well, twice. Like here, as we can see, the results are in favor of Bun, and in all of the cases, this is basically x2. Here, yes, it's 0.5, but the more requests per second the server can handle, the better. So Bun.js handled 31k requests per second, while Node.js handled only 14 requests per second, which means that if you're getting a lot of requests to your server, Node.js will be able to handle half as many compared to Bun on the same machine with the same performance. This is based on the test that I'm running. Now let's go ahead and do the same for the feed endpoint, and we're gonna do it to the feed here. So in total it took 10 seconds. Let's write this down, 10 seconds. Request per second average 10k. Request maximum 15k. Latency average 12.45, and throughput was 821. So as you can see, Bun in the second use case, it's still faster compared to Node.js, but this time it's not as significant. It's not like twice or something like that. It's marginally faster because yeah, like at the end of the day, like behind the scenes, what this /feed is doing that is taking a lot of time is interacting with a database. And here both Bun and Node.js is using the same SQLite database, so the performance is not on the runtime but rather on the database. So yeah, when you add more complexity to that, like the performance, in my opinion, as we can see here, is still better but not as significant as when we are comparing like a simple hello world endpoint. This is because, in my opinion, Bun has cut down a lot and improved the performance around the overhead that is happening when doing all of these requests, like the small overhead of receiving and handling the request. And that's why it's so visible on Hello World examples. Anyway, another thing that I'm really impressed by is how simple it was to replace Node.js and the Node.js tools like npm and npx with Bun. We didn't have to do anything. We simply replace it. We installed and we run it with Bun runtime. And yeah, I think that was on point. And I'm not sure how well it's going to replace Node.js in any kind of project, but as they say, it should work in most of the cases. On their website, you can also see the status of other tools running in the Bun ecosystem. So if you're interested, you can check it out here. For example, if you're working with Next.js, you might see that the Next.js app router currently relies on notJust API that Bun does not implement yet. So it will be available later, but now it's not. And if you are using app router, because if you're still on the old router, then everything is going to work with Bun as well. If you're using the new router in Next.js, probably you still rely on Node.js. So yeah, have a look at different tools in the ecosystem to see the support, and also in their documentation there should be more information, yeah, about what is supported and what is still work in progress. Okay, all right. So we saw how easy it is to replace, and we have done some benchmarking. We actually saw for ourselves that indeed Bun is taking way less time, especially around installing Bun as a package manager. Here is where we get a lot of benefits, very fast install of our packages, especially when they are cached, when it's not the first time we are installing them. In those cases, we see up to 137 times faster results. So if the backend took 8 seconds to install with NPM, it took only 58 milliseconds to install with Bun. So yeah, we saw that with Expo application as well. Yeah, anyway, what I want to do next is I want to start fresh. I want to start clean. Like, we saw how it performs in existing projects, but I want to get our hands dirty with the actual way that Bun is supposed to be used as with the Bun HTTP server. I want to create the simplest server, but to create it ourselves, and maybe also do some performance testing as well, and also see how we can use native APIs that Bun is including out of the box, that we don't need any additional packages, and to see how we can use them for ourselves. And here I'm talking about the files, how we can manage files, how we can read files with Bun, the JSON support, SQLite, password hashing, and maybe something else that you might be interested. So still a lot of things to cover. We are doing pretty good, but I want to stop for a second here and ask you a big favor. I'm pretty sure that if you are watching this video up until this moment, that means that you are learning something new, you are taking something valuable for yourself, because otherwise, why would you stay here if it's not interesting? So if you are actually learning something new, if you find this valuable, please help us reach our goal by the end of this year. We want to reach a very, simple milestone, but quite important for us. We want to reach 100,000 subscribers. We are currently at 83, and this is the goal for the last 3 months of a year, so we are only 3% in. If you can pause the video, hit the subscribe button, it only takes you a couple of seconds. That would mean a lot to us, and it will help us get closer to our goal. Anyway, let's get back. Let's check our documentation, our guide, and we can go to native Bun server versus Node.js native server. All right, so I'm gonna start by closing the VS Code here. In the terminal, I'm going to navigate back to my directory where I keep all the codes and projects for this tutorial. We already have 4 projects here for the Prisma examples and others. And what I want to do now is let's create a new folder for the last experiment, and this is going to be our HTTP servers. So let's do HTTP servers. Let's navigate there. And inside it, let's create two folders, one for Node.js and one for Bun. Make dir Node.js and make dir Bun. Now I'm going to open the whole folder here, which will include both Bun and Node.js projects to have them side by side. And let's go ahead and first start with a Node.js server. Previously, what we tested was an Express server, which is built on top of the HTTP package. And now I want to dive lower, one level lower, directly running or creating an HTTP server in Node.js. Without Express, without any dependency, out of the box, as Node.js is coming, it has the HTTP module. Let's create it with that. And then let's do that same with Bun.js. But first, in Node.js, we're going to have to create the index.js file. And here, I'm going to go and grab the VS Code for the hello world for HTTP Node.js server. It is as simple as this one. The HTTP module comes with notJust runtime. We can create the server and we can respond with a hello world. It will listen at port 3000. Let's open a terminal. Let's run this with Node, and we're going to do this by running node.js index.js. The server should already be running, and I think we can simply send some request with bombarder there. The port is 3000, and here is our Node.js server. Very blank, minimum HTTP Node.js server. So let's go ahead in our spreadsheet, and let's do here a new line. A new line saying HTTP server. Now I'm gonna take probably the same statistics. It took 2 seconds in total. Or actually I wanted for this bombardier to run more tests. Rather than 100K, let's increase it to 1 million. Let's do that. One M requests from 125 connections. So yeah, now this takes a little bit more time, but it's going to be easier for us to compare the numbers. It took 26 seconds in total. 26 requests per second on average. It was 38,000, and maximum request per second that it managed to handle was 47. Now in terms of latency, the average was 3.23, and the final throughput was 794. Okay, we're done here. We saw how the HTTP server performs with Node.js. Let's do the same with Bun. We're going to go ahead and create a new file in Bun called index.js. And here from their documentation, you can find, I think even from their homepage, if you scroll down to the start HTTP server, this is the code that you need. I also have it in the guide for you. Let's copy paste it. I think for this one I use the port 3001 just to have a different port. And what we can do is right away, I'm gonna stop the Node.js server first. And let's run the Bun server. We're gonna do that by running Bun. The folder is bun index.js. This is listening, and we can send the same requests, the same 1 million requests to our Bun server. Let's do that and see how it performs here. So it took in total 14 seconds. Total time, 14 seconds. Requests per second average, right? 70K. So it's almost twice as much. Maximum 90K. Again, almost twice as much. Latency average 1.77 milliseconds. And throughput 1298. So yeah, with a very minimal like HTTP server, when we compare Node.js with Bun, we again see that the almost twice as fast performance for Bun in all of our metrics. Less time to handle them, more requests per second. And for the maximum request per second, Bun managed to handle 90K requests, while Node.js only 47,000. The same half the latency, which is better because it's less time waiting, and the throughput, which is the amount of data that went back and forth. Because it managed to handle them faster, it's also more. Is it? Probably. Okay, so that was a simple HTTP server with Bun. But the benefit of Bun is not, they are putting a lot of emphasis on performance and that is fast. But another area where Bun is trying to improve the developer experience compared to Node.js is to simplify the complexity of the whole toolkit that you need in order to run, build, and test JavaScript applications. With Node.js, everything is a package. Like if you need a transpiler, you need a package to install a package. If you need testing, you need Jest. If you need TypeScript, you need the TypeScript. You need to compile the code back to the JavaScript. If there are so many more packages out there that you need to run a simple application with Node.js. Bun is trying to simplify this by coming built in with some of these tools. So what I want to do now is explore some of them that I think would be important for a lot of developers out there. And the first one is out-of-the-box support for TypeScript. So with Bun, we can simply replace this index from GS to TS. And without any changes, we can do Bun and run this file. Well, doesn't seem like that because the server is already running. So I need to do TS here. So as you can see, Bun is able to run TS files. Here a note is that in order to do type checking, you'd still need the TypeScript and TSC. But you don't need to transpile the code back to JavaScript in order to run it. You can give Bun TS files and it will simply remove all the types and run it as a JavaScript. That's cool. That leaves us with one last tool that we should use there. While we're still on the TypeScript, we see that at this moment our editor doesn't understand that there is a global Bun, and that it says that it cannot find this name. What we can do, the easiest way is to go ahead and navigate to our Bun folder. And the easiest way to solve this issue is to use Bun init -y, and this will initialize the package.json. And what we actually needed there in the package.json is the bun types dependency that provides the types for the global bun instance. And in the tsconfig, it automatically sets it here under the types. So that with that, now we don't have any problems here. And we're gonna have autocomplete out of the box when we run, for example, bun.something. For example, bun.file. So this is the TypeScript support. You can do that yourself by installing bun types in your application, in the dev dependencies, and in tsconfig adding bun types, or simply doing bun init if it's a new project. Now, speaking about files, let's see how easy it is to read files from the file system, because bun, if you go to the files here, I left a link to the documentation where you can learn more about the bun file and how to work with it. I'm going to show you in a simple example. For example, if I'm going to have here a hello.txt file where I'm going to write, I don't know, hello world. And if we go to the index.ts here, instead of welcome bun, I want to read the content of the file and return that. To do that, what we should do is simply create a file using bun.file. Here, give it the name, the path relative to the root directory, and the path is hello.txt. Now, you can access the content of this file in a couple of ways. You can do that with file.string. Is it string or text? It's file.text, and this will return the content of a file as a string text. You can do that with file.arraybuffer to access it as an array buffer, and a couple of other ways, for example, to JSON, to a stream. You can also transform it to a stream. What I'm interested in is to read it as a text file. So if I do that here, instead of a text, I will need also the async before the fetch, but at the end, if I'm going to rerun our project, where is it? Bun index.ts, and if I'm gonna go to localhost 3000, we should see hello world. If I'm gonna change the text here to anything and restart, it's updating here because it reads the content from the file. And yeah, I think that this is quite easy and simple way to read from files. You don't need to handle the read streams and buffers and so on. You simply want to read from file and transform it to a text. You can do that out of the box with bun. While we're still here, I wanted to show you hot reloading. For example, if I change something on our file, on our code, for example, if I will change, I don't know, I want to add here something at the end, If I'm gonna add this, our project will not, our server will not refresh, and the changes will not be there. With Bun, you can watch files, you can run and watch files, and to do that, you will do bun, I think -- watch index.ts. Now it's listening on our server, but if I'm gonna do some changes, it's restarting, as you can see. So now at the end, we should see this SS, and offline, it's restarting automatically, and we see that here. So the watch mode works automatically. It automatically restarts the server, And for front-end applications, you can also do hot reloading, where you don't have to restart the whole server. It automatically reloads that part of a code that you changed and hot reloads it on the application. So you have like much faster development experience. Can I add this Bun 1.0 to my existing Next.js 13 applications? If you're not using the app router, yes, you can. Wait. Starting from the Bun as a package manager, the answer is yes. You can use Bun as a package manager in any JavaScript application. Basically, if you have a package.json in your project, you can remove node modules. You can remove, for example, package.log and run Bun install and start managing your packages with Bun. The next time you have to install a new package, you do bun install the name of a package, and you continue as you would use npm. Now you can use Bun. That's the easiest way. There is no reason why not to do that, and you're gonna have like faster installation times. To use Bun as a runtime for Next.js, you can do that. You can do that locally. And if you're not using app router, because I read in the documentation that the app router is not yet supported, it still needs depends on Node.js. So yeah, that's it. But if you're deploying, for example, Next.js to Vercel, in this case, there is nothing much that you can do, as I understand, because Vercel will decide what runtime to use. Maybe they will add support both for Node.js and Bun. Maybe it's already there. I don't know. I might be wrong. But yeah, locally you can do that. If you self-host Next.js, you can do that. If you're running on Vercel, it depends on Vercel if they support it or not. Anyway, back to our application. What I was doing, I was working with files. Yeah, with files. A very specific type of file. We saw how to work with text. But in a lot of cases, what we're actually using is JSON files. So let's see how we can do that with Bun. I'm going to create a post.json file that has a simple JSON array with 2 posts. In our index.ts, what we can do is, there are 2 ways to import it. The first way is also with creating a file with Bun file, and here let's call it posts.json. And when we want to read the files, what we're gonna do is we're gonna call file.json. And this will read the content and return it as in the JSON format. Now, instead of returning new response, I will have to actually return response.json to specify that this is a JSON object. And now if I'm gonna go, the server should automatically restart. And if I go here, I see the JSON file returned from our API. So it's that easy. It's the same syntax. We create the file with bun.file, and using file.json, we are taking the content and transforming them to the JSON. Another way to import a JSON file is importing it directly as you would import any other file. For example, import posts from post.json, and here we can return posts like this, and it's supposed to work, hopefully. Yeah, we don't see any errors. No. So yeah, this is also possible. The first way that I showed you is you would use this one at runtime, like maybe when the name of the file is dynamic, where you're generating it. And the first one, you would use it when the file is there from the get-go, and it can be accessed at build time. Anyway, that's the way how we can work with JSON files. It's quite simple. Now, what if you need to manage a database? A simple database like the easiest way to add a database to a Node.js project is definitely using SQLite. The SQLite is a light version of a SQL database that simply works by writing stuff to a file. It's not like a real database. It stores data in a file, and it allows us to query it using the SQL syntax. A good thing is that Bun has support for SQLite out of the box. So if we're gonna go to the documentation here, we're gonna see that Bun natively implements a high-performance SQLite free driver. To use it, we simply have to import it from Bun SQLite like this. So I prepared here something. Let's go ahead and see how to work with a database like this. And the first step is to import database from Bun SQLite and create a new database. In our server, let's do that. As soon as I save this, we see a new file being created in my project, and it's called mydb.sqlite because this is the name of a file that we created the database with. So that's where all the data is going to be stored later. Now that we have a database, we can run queries on this database. The first query that I'm gonna run is here at the top. As soon as we create the database, I will run a query to create a table called history. This table will contain 3 columns: ID, the time when a request has been registered, and the URL, or the path where the user has requested it. So it's going to be a simple database, and every time someone sends a request to our server, we will write a new line in this database to be able to track how many requests and to which path of them in the application it have made the request. So very simple, just a tracking mechanism, let's say. Now what we can do is we can insert the URL inside our table, and we're gonna do that inside this fetch where we handle the request. So the first step is we can take the URL from the request.url, and with a simple SQL query, we're gonna insert into the history table, and we're only going to insert the URL because the ID and the date time, they will automatically, for example, the ID will automatically auto increment and the date time will default to the current date. But the URL is going to be a variable that we will send to these values. That's why we have !1. Now, when we call the query.run on the next line, we are sending the path name where this request has been sent. Now, without any changes, if I'm gonna refresh this, nothing changes, but I think I expect a new line to be added to our database. Not sure if I'm gonna be able to visualize it, probably no, but what I can do is I can execute another query to get all the data. So to read the data, we're gonna use this select query. So we're gonna select all the columns from the history table, and we're simply going to order by ID. And we're gonna take all of them and return it back as the history. Now, if I'm gonna go and refresh this page, we see a request being made at 15:41, which is my current time, to the /URL. If I'm gonna refresh it, it's gonna add one more. So basically the last one is the request that we are doing currently. So if I'm gonna do here /hello, we're gonna see this data registered in the SQLite database. And yes, this is all powered by the SQL driver that is coming pre-built with Bun and is quite simple. I'm not sure if we can do any performance testing. I think it would make sense to do performance testing on the notJust SQL driver and Bun's SQL driver, because based on their documentation, and if we believe them, that means that the Bun SQLite module is roughly 3 to 6 times faster than the better SQLite 3 and 8 to 9 times faster than the Denoland SQLite. So yeah, it seems to be quite fast. But most importantly, it comes out of the box. We don't have to install anything additionally. And it does its job. So that was our SQLite driver. The last step that I want to show you is some cryptographic operations that are possible with Bun, because Bun has also like the crypto module out of the box. We can read more about it here on their documentation. And yeah, it's able to create hashes, and it also implements some very specific features related to hashing around passwords, because this is something that we all do, what is manage passwords in applications. In all applications, you need to hash a password, save it, and later verify it if it's the match. So with this simple, you don't even have to import anything. What you can do is, having a password, you can hash it using the bun.password.hash, and later on you can check if a new password matches the hash. You're gonna save this hash in the database, and later when the user wants to either change the password or sign in, you're gonna compare the string that you receive from him with the hash using this verify method. So what you can do here is you can do console log hash, and here console log is match. And if I'm going to send a request and come back here, we're gonna see that this string, this super secure password, was hashed to this hash, and when we compare it back to the hash, it says that it matches, it's the same password. So yeah, again, it's quite simple. Out of the box, bun.password, we can do that. I'm going to probably delete it from here. You can explore more possibilities under the hashing. You can use it not only for passwords, but for any types of hashing that you might need in your application. You can also change the algorithm that is being used for the hashing. These are the supported algorithms. Pretty cool. What about MySQL? For MySQL, you would have to use an external driver. So it doesn't come with MySQL. I think it comes with SQLite because it's so light. I mean, if you would add all the drivers out there for all databases, it would mean that you have to support a lot of things. But SQLite is something that helps you get started, and later you can easily switch to Postgres or other SQL databases from SQLite. Or also, if you're working with Prisma, you can start using Prisma with SQLite and later just switch it to Postgres when you go to the production. And guys, that was everything that I have prepared for you for today. We have covered quite a lot today. We started by looking at Bun as a package manager. As a package manager that simply helps us manage notJS or npm packages in our application. We saw that it's way faster than npm, especially the second time you run it, because it caches packages globally. For example, yeah, in a lot of cases it was at least 5 times to 10 times faster, but when it was using the cache, it was almost 130 times faster with Bun compared to npm. Then we also experimenting how is Bun as a drop-in replacement for Node.js as a runtime, and we took a full stack Node.js application that had the backend, which was a REST API built with Express, and the frontend was a Next.js application. We ran that with Node.js, and after that we have done the same with Bun. The good thing is that we didn't have to change anything to make the same applications work with Bun as a runtime. So that was very good to find out, because that means that it's super easy to replace Node.js with Bun. You don't have to invest a lot of resources there. Probably in a real use case, you'd have to test a lot of things to make sure that your application is working on Bun runtime the same way. I would expect some of the things not to work. Some of the things, some edge cases here and there, especially if you have a more complex application. But for simple application and for what we have tested today, everything worked as a simple drop-in replacement. Then we have done some performance testing on both Node.js and Bun as a runtime. And here, in a lot of cases, we saw twice as better, how to say it? The Bun was performing twice as fast as Node.js, or faster, I would say, in most of these use cases. It was able to handle twice as much request as Node.js was able to handle, and we saw that throughout multiple use cases, even with a simple HTTP server. When there is when the endpoint or the server is doing more work other than hello world, in that case, the performance difference decreased a bit. Bun was still much faster, but in this case, we see that it's not twice as fast. It's like, I don't know, a bit less. But anyway, it's quite fast. And in the end, we have saw some of the ecosystem that comes with Bun, some of the pre-built tools that we can use that help us with building, managing, installing, testing our JavaScript and Typescript applications. There are so many more things that you can play with. You can go ahead and see the test runner. This one is something that I wanted to cover today, but I thought it's going to be too much for one video. So with Bun, Bun has a built-in test runner, so you don't need Jest. And it's very similar to how Jest is working. So for that reason, most probably you're going to be able to reuse a lot of tests. What else I was interested in? WebSockets, something very interesting. Bun supports WebSockets on the server side. Yeah. If you have any questions, guys, feel free to ask. I'll still see if I can replicate my Node.js GraphQL server with Bun. When you say replicate, I hope you don't mean having to rebuild everything from scratch. Because Bun, as I was mentioning before, is a drop-in replacement for Node.js, which means that in a perfect situation, you don't have to change anything. You only swap notJS to Bun, and it should work. So what you can do is simply remove node modules, remove package.log or yarn log, install Bun, install all the dependencies with Bun using Bun install, and after that execute or run your server with Bun. Instead of node index.ts, do Bun index.ts. Give it a try and see how it works. And if you don't see any problems, you're good to go to use Bun for your project. That would mean like locally. If now it depends where you deploy. And if you deploy on a simple like EC2 server, in that case, you have the flexibility to go ahead and change the runtime from notJS to Bun. However, if you are deploying to a low-code solution or let's say a backend as a service, in that case it might be a bit harder. Bun is worst. If you use Next.js 13, my second refresh page after deploy fresh up, it broke the Hello World application. Is the Hello World application using the app router? Are you using the app directory or the pages directory? Because from Bun documentation, and by the way, Bun is not sponsoring this video, and I'm not here to say anything good about it. I'm here to explore. So please, if you find anything that is not working, I'm interested in that. If you think that my performance were not, my performance tests were not correct, please let me know down below how I can do them better. I'm simply curious to find out. And one thing that I saw is that, yeah, like maybe the Hello World is too simple, and that's why we see so much difference in performance. That's why I tried a different endpoint. Yeah, if you have any other ideas how we can put this to test, I'd be happy to hear them. So can I expect any application with Bun? Let me see the previous message that you asked. What do you mean, can I expect any application with Bun? Any JavaScript application is supposed to work out of the box with Bun. But realistically, there are still things that are not working. So test it and be careful. And a good way to where you can see what's supported or not, go ahead at the end of this page, and there is the on the bun.sh homepage, there is a list of Bun with. So if you find the framework, the tool that you are using, for example, if you are using Remix, you can see here more information about that. At the top, you see currently Remix development server relies on Node.js API that Bun does not implement yet. The guide below uses Bun to initialize a project and install dependencies, but it uses Node.js to run the dev server. So how to understand this message is that if you are a Remix, if your project is using Remix, that means that you can use Bun as a package manager, but not yet as a runtime. With Node.js, with Next.js, the note is that the app router currently relies on Node.js, which I understand as if you are not using the app router, if you're still using the pages, then it should work. And we saw that in my case it worked, which was not using app router. So Next.js with pages should be working with Bun runtime. And yeah, and so on and so forth. Can you do a React Native video about payment gateways? React Native video about payment gateways, a very good question right now. And I'm not sure if and when we're gonna do it on YouTube, but I'm sure about when we're gonna do this with our private community. It's gonna be tomorrow. So tomorrow with our pro community, we are running an advanced app development with React Native. And in this workshop, I'm gonna teach how you can implement payments. I actually asked our Discord community, where is it? I had 4 topics in mind to cover in this advanced workshop, they being payments, push notifications, yes build, and yes submit. And as I see, 10 people wants to see payments and the push notifications. I think these are the 2 features that we're gonna cover tomorrow in the workshop. And if you are interested to join this workshop, it's not late yet. You can go ahead and become a pro member by going here, notjust.dev/pro. And you're gonna become part of our private community. We're gonna have monthly calls with me every month, and dedicated and exclusive workshops like this one that we're gonna have tomorrow. Also, you will have access to all the past workshops that we have done. So even if you see this video in a couple of months and you're interested in learning about payments with Stripe in React Native, you can join our pro membership and you're gonna have access to the workshop that we are gonna do tomorrow. So yeah, it's only $24 per month. It's quite cheap, but we are doing a lot of dedicated workshops and calls with our community. Anyway, guys, let's see if we have any other questions. I've seen app router with Bun worked, right? With Bun create next app. That's interesting. I could give it a try. All right, guys. So thank you very much for being here with me till the end. I hope you found this video interesting. And if you did, make sure to subscribe to the channel. Help us reach 100K by the end of the year. And let me know in the comments below what other tools or things that are new out there I should give it a try in our next videos. Yes, that's it. I'll see you next Friday, also live here on the channel. Have a nice rest of the day. Bye bye, guys.